Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next video. In this video, we are going to solve 9 problems of mathematical methods in physics. Okay? All these 9 problems have been chosen or taken or selected from the book Advanced Engineering Mathematics by Dennis G. Zill. As usual, we first come to its statement of first problem. Okay. MMP Mathematical Methods in Physics, problem number 26. Compute gradient of f xy for f xy equal to 5y minus x3y square. Okay, dear students, hereinafter we will also see a snapshot in which some detail about gradient will be given. Okay, anyhow, here we are directly solving this problem. Okay, fxy is equal to 5y minus x3y square. Now gradient of fxy will be equal to partial derivative of this with respect to x plus partial derivative of this with respect to y, but not partial derivative of this with respect to z, because z is not present here. Okay, it is only two-dimensional, only x and y. Okay, when z is also given, then we also take its partial derivative with respect to z. Okay, however, that is not the present case. Okay, dear students, this symbol is sometimes called curly, sometimes called partial, because it is a partial differentiation. So gradient of fxy is equal to curly over curly x or partial over partial x into 5y minus x3y square I plus curly over curly y or partial over partial y into 5y minus x cube y square j. Dear students, partial differentiation of this factor with respect to x will be 3x square y square and with minus sign. Okay, and partial derivative of this factor with respect to y will be 5 minus 2x3y1. Okay, we move forward. This is equal to minus 3x square y square, because with respect to x, plus 5 minus 2x3y1. Okay, this is the answer of this problem. Now we are going to a snapshot in which some introduction or some detail about gradient of a function is given. Okay, it will help us in understanding this problem more properly. Okay, the gradient of a function. In this and the next sections, it is convenient to introduce a new vector based on partial differentiation when the vector differential operator del or nabla equal to I curly over curly x or partial over partial x plus j curly over curly y, or del is equal to I curly over curly x or partial over partial x plus j partial over partial y plus k partial over partial z. What is the difference between these two? It is only to the extent of x and y, while it also includes the z axis. Okay, is applied to a differential function, to a differentiable function z equal to fxy or w equal to fxyz. Okay, this is only to the extent of xy. This is, it also includes z. Okay, we say that the vectors del fxy equal to partial f over partial xi plus partial f over partial yj, or del capital F x y z is equal to partial f over partial xi plus partial f over partial yj plus partial f over partial zk are the gradients of the respective functions. The symbol del, an inverted capital Greek delta, is called del or nabla. Okay, it means this is del or nabla, but if it is inverted, then it becomes delta. Okay, the vector del f is usually read grade f, gradient of f, gradient of f. Okay, del f is read as gradient of f. Dear students, now we are going to next problem. Now we will not give so much time, okay, because same procedure is adopted in the remaining problems. Actually, dear students, this video solves 9 problems. Okay, out of these 9 problems, first problem has been taken as an from an example, while remaining 8 problems have been taken from exercise. Okay, one example, 8 exercises. Actually, dear students, this trend is very essential here, because typing a problem of mathematics in math type software is very difficult and very laborious. So after typing one example, then exercises become easier, because same pattern is followed and only copy paste version along with relevant changes works. Okay, otherwise, for example, from this video, if I take only one problem, first problem which was example, or any one other problem from these remaining 8 problems, then speed of my channel will be very slow. Okay, problem number 27, mathematical methods in physics. Problem number 27, compute the gradient of fxy equal to x square minus x3 y square plus y raised to the power 4. Okay, solution. Dear students, I do not explain much. Everything is written, everything is given. Okay, partial over partial x, this factor, it will become 2x minus 3x square y square. Okay, 2x minus similarly remaining portion. Okay, similarly remaining portion, and finally this I plus j, this becomes okay. I think it is enough. Now we move to next problem, mathematical methods in physics. Problem number 28, compute the gradient of xy equal to y minus exponential function minus 2x. This is a slight tricky, because here we will have to differentiate it partially. This is it needs a little explanation. Okay, this one, fxy is equal to y minus e raised to the power minus 2x square y. Now del f or gradient of xy equal to partial over partial x this I plus partial over partial y this j. Okay, now dear students, when we differentiate it partially with respect to x, this minus will remain. Okay, now actually we will first differentiate this portion minus 2x square y. partial differentiation will become minus 4xy. So this minus is this minus, and this minus 4xy is the differentiation of this, and next to this, the whole this factor will be written as it is. Okay, while in case of partial differentiation of this with respect to y, this y will become 1, and we will differentiate this upper portion first with respect to y. So here y will become 1 minus 2x square. Minus 2x square will be written along with the minus, but then this minus will become plus, minus into minus. Okay, so plus 2x square in place of y1, and then whole of this factor as it is. Okay, so after simplification this becomes this. Okay, mathematical methods in physics, problem number 29. Compute the gradient of fxyz equal to xy square over z cube, z raised to the power 3. Okay, now what change has been observed? The change is that here z is also involved. So dear students, fxyz is equal to this, then del f or gradient of fxy. Oh yes, minor there is a minute mistake here. Z should also be written. Okay, del f xyz. Oh, I admit this is a minor mistake. It can be rectified during the lecture, but it may cause trouble. Okay, our system may be hanged, so I do not remove this mistake. I verbally tell that here z will also come. Okay, so partial over partial x, this factor plus y plus partial over partial z kiye. Dear students, with respect to x, when we will do here, x will become 1 and remaining factor will as it is. Okay, y square over z cube. When with respect to y, then 2 will become here and it will be become 1 less, that is 2xy over z cube as it is. Then when with respect to z, this z will be treated as in the denominator with the z raised to the power minus 3. So minus 3 will become here, and this minus 3 will become 1 more less, that is minus 4. So z raised to the power minus 4 means z raised to the power plus 4 in the denominator. Okay, so this I think it is solved. Okay, now mathematical methods in physics, problem number 30. Compute the gradient of fxyz equal to xy cos yz. Oh, sorry, the same mistake is going on. Actually, as I have told dear students, that only one in such nature where 8 problems are being solved, in which one problem has been taken from example and remaining 8 problems have been taken from exercise, only one problem is solved in depth, and then remaining all parts work on copy paste version. Okay, so this mistake will run even in the next problems. Okay, so dear students, here when we partially differentiate with respect to x, this x will become 1 and remaining factor will as it is. Okay, y cos yz. When with respect to y, this y will become 1. Now it will become a slight complicated. Okay, one time we will partially differentiate this and one time we will partially differentiate this. Okay, so one time in place of y we will get 1 and hence x cos yz minus differentiation of cos is minus sign and this z will become out of this, so xyz into sine yz. When with respect to z, then simple, then not two steps, only one step, minus xy square sine yz. Okay, so after further simplification it becomes this. Okay, I think it is solved. Now we move forward. Mathematical methods in physics, problem number 31. Find the gradient at the indicated point. Here the process method is quite same. The only difference is that at the end we have to put 2 in place of x and 4 in place of y. Okay, no more complication. Fxy is equal to this, del fxy. This is correct. This is, there is no mistake because it is already in only 2 coordinates xy. Okay, so this here it will become 2x only. This factor will not be treated, it will be treated as constant. In case of y, this will be treated as constant and it will become minus 8y. Okay, so 2xi plus this. Next we will put 4 in place, 2 in place of x and 4 in place of y, so it will become 4i minus 32. Okay, mathematical methods in physics, problem number 32. Find the gradient at the indicated point fxy equal to under root x cube y minus x raised to the power 3y minus y raised to the power 4 at points 3, 2, that is x3, y4. Dear students, this is okay. Dear students, actually its method is that under root is equivalent to power 1 by 2. So first we will take 1 by 2 here, and this 1 by 2 will be made 1 less, that is to say 1 by 2 minus 1, it will become minus 1 by 2, and minus 1 by 2 means 1 by 2 in the denominator. So this under root will become in the denominator, and along with this we will get 2. Okay, and then the internal portion will be differentiated partially when needed with respect to x or y, or but only x or y, there is no z. Okay, so I think clear. I think I should not give more time to these steps. Okay, okay, in the last we have put the value in x, x in place of x we have used value 3, and in place of y we have used value 2. Okay, so I think it is quite okay. Okay, I think we should move forward. Okay, mathematical methods in physics, problem number 33. Find the gradient at the indicated point fxyz equal to x square z square sine 4y at points minus 2, pi by 3 and 1. Here pi by 3 means 60 degree. Okay, because pi is taken as 180, so means 180 by 3, that is 60 degree. Okay, anyhow fxyz equal to this, del fxyz equal to, here is no mistake, here matter is correct. That mistake was only in one problem. Okay, here del f for gradient of x, y, z, all the 3 coordinates are written, so no mistake here. Dear students, when we will differentiate it partially with respect to x, it will become 2x. Okay, 2x, and the remaining portion as it is. When we will differentiate it with respect to y, then this will become cos 4y and 4 will be written outside. 4 x square z square cos 4y. Okay, sin 4y will become cos 4y and this 4 will be written outside. Okay, so I think in the last we will put values of x, y, z. Okay, when we put values of x, y, z, then gradient of f or del f becomes equal to this. Dear students, here one step more can be done, but it is just a matter of discretion. Okay, so I have not done that step. Okay, what is that step which can be made? That step is that dear students, value of sine 4 pi by 3 can be found from tables. Similarly, value of cos 4 by similarly here once again value of sine 4 pi by 3 can be taken from table. Actually, dear students, pi is 180. 180, then when 180 is divided by 3 it becomes 60. When 60 is multiplied with 4 it becomes 240. Okay, so accordingly it can be solved one step more, but it is a matter of discretion. To this extent our answer is 100% correct. Mathematical methods in physics, problem number 34. Find the gradient at the indicated point fx y z equal to log x square plus y square plus z square at the point minus 4, 3, 5. Dear students, differentiation of log is always 1 over that value into differentiation of internal portion. Okay, so fx y z equal to log this at point this, del f or gradient fx y z is equal to partial over partial x this plus partial of partial y this plus partial of partial this. Okay, dear students, as I have told that differentiation of log into something is 1 over that thing into differentiation of that thing. Okay, so here 1 over x square plus y square plus z and here 2x. Similarly, in case of y only 2y and in case of only 2z in case of z. Okay, so quite simple. Ijk 2x 2y 2z. Okay, now in the next step we will just use the values in place of x minus 4, in place of y 3 and in place of z 5, and hence our answer will become minus 4 by 25i plus 3 by 25j plus 1 by 5k. And this is the end of our video consisting of 9 problems. This is the end of our video. This is the end of our lectures. Till next video, Allah Hafiz.